Hey guys, welcome to Video Math Lessons, and tonight we're going to look at a Math 12 Pre-Calculus class. Topic is polynomials, and this is a mixed review. Alright, so somebody requested a mixed review for the giant polynomial questions. So hopefully you printed the PDF and you tried it, and now we're kind of going over it together. So let's take a look first off. So it says, Part A, using Descartes' rule of signs, determine the max number of positive and negative roots. Well, Descartes' rule of sign says we got to count the sign changes. So f of x will be for the positive roots. So we'll take a look at this. So you pretty much just look at the original sign. So it's positive, negative, negative, positive. So I count the sign changes. So it changes once, stays, changes twice. So I have two changes. Now that would be two positive roots, but they could be imaginary, so we subtract off doubles. So we take off 2, so it'll be 2 or 0 positives. And then we're going to try f of negative x will be for the negative roots. Now when I plug in a negative in the cube, that gives me negative, so that would be negative. Negative squared is positive, times the negative, though, stays negative. Negative times negative is positive. The 6 is always positive, the constant. Count the sign changes. I have one change. I know for a fact there is one negative root. It's part A. Part B. Use the rational root theorem to make a list of all the possible zeros, the roots. So what we do is we factor the back over factors to the front. So we're going to break down 6. So it'll be 1 times 6 and 2 times 3. And it's all the variations, so it's positives and negatives. And factor the front, 1 and 2. Positives and negatives. So now we do the fraction here. So I divide everything by 1. I get what I started with. So it'll be 1, 2, 3, 6. And then we do the fraction. So I get 1/2. And what else? We get 3/2. We don't do 2 over 2 because I already did that. It's a 1. I already have that number, so I don't rewrite that number. So that's that. Find all the roots and show using synthetic division. Now, I can do just random guessing the roots, but what I'm going to do is instead is I'm going to punch in the equation, see what roots are there, and just pick out the, I'll do synthetic on the ones I know work. Now, technically, you should be able to do this without a calculator, but it's going to take a while without a calculator because you're going to hit wrong numbers. So 2x cubed minus 5x squared minus x plus 6. I hit graph. There's that one negative, and there's two positives pretty tight, close to each other. I could go to the table set, and I'll fix that back to auto. And I'm just going to... So I see there's a root at -1 and 2. The other one's a fraction. I'll find the fraction later. Now, I could have left it here, just plugged in these fractions here, but we can find it by just actually doing the problem. So I'm going to start with 2. And so I put the root inside, and I take the coefficient. So it's 2, -5, -1, 6. Do the division, so I bring it down. So 2, 4, -1. We got -2, -3, -6. You get a 0. That tells me this was a root. And I know positive -1's a root, so I'll do -1. I'll take this problem, this new equation. Now this was x cubed to start with, now it's x squares. So 2, -1, -3. Bring down, So we got negative 2, negative 3, positive 3, 0. That tells me this was a root. Finally, I have this new little baby equation. So this would be x's. So it's 2x minus 3 equals 0. Move things over. X equals 3 halves. That's my last root. So I have, what do I got here? I got negative 1, 3 halves, and a positive 2. Those are my roots for this problem. Part D, create this number, the sign chart. So I had my roots, so negative 1, 3 halves, and a 2. Now they're roots, so I can call those in the solid. And I want to pick some numbers that are off. So negative 2, 0 would be good. Let's say 1.75, and positive 3. I can go to my table, bounce around on this thing, and I've already done this, so I know it's negative, positive, which I also know from the graph. I see it. Now, what does this mean? So at negative 1, that's a root. At 2, it's a root, so let's call it 1, 2, and a half. So I got a root here, here. I can look at my intercept, and I see that the back number is a 6, so I know it'll cross up here at 6. It's not totally to scale. And that's enough to start. So let's say now, from negative 1 to the left, it's negative. That means it's below. And then at negative 1, 0. Then from here to here, it's above the x-axis. So it goes up. And then it just dips down below, and then it goes up. That's my curve. So f of x, I labeled the chart, they have the graph a little bit, got some numbers on there, I can tell the zones. So that's the curve. Describe the end behavior. Now, the curve looks something like this. So as x goes to infinity, the curve goes up, heads towards positive infinity. As it goes to negative infinity, the curve goes down. So that's negative infinity. Part G, show that 3 and negative 2 are the upper and lower bounds for the polynomial. So what I do is I do the 3, and I do synthetic division on the original. So 2, negative 5, negative 1, 6. You know it's an upper bound if after I do this, it's all positive. That's how you can tell. So 6, 1, 3, 2, 6, 12. These are all positive. That's how you know it's an upper bound. So that's the upper. Do it again. Negative 2. Keep my numbers 2, negative 5. Now this time I'm not going to the new equation. I keep the original. 2, negative 5. Negative 1, 6. And if this is the lower bound, we will get alternating signs, positive, negative. So 2, negative 4, negative 9. Positive 18, positive 17, negative 34. And that gives me a negative 28. So these have remainders, doesn't matter. I'm not looking at that because I'm looking at the sign. So positive, negative, negative. Alternating signs. That means this is a lower bound. And the last part, find the remainder using the remainder theorem when f of x is divided by x minus 1. So the value I'm going to use is positive 1, right? And you plug it in. That's all you do. So 2 times 1 cubed minus 5 times 1 squared minus 1 plus 6. And then kind of do it. So that's a 2 minus a 5 minus a 1, and that's a 6. Clean this mess up. Negative 5, negative 1 cancels a 6. So the final answer is a 2. Oh, that's it. Hopefully it helped. So have a nice night. Thanks.